Welcome back. In this video, let's understand the Google Earth Engine code for mapping NDFI. This code is elaborated well in Souza et al. 2024 as discussed in the last video. In the code, we are filtering the Landsat 8 image collection for a specific year. Here I have considered 2024. Then we are taking the median of all the images within that year to create a cloud-free composites representing the typical spectral conditions. If you want to analyze by a specific area of interest, then you can use .filterbounds within geometry which focuses on a particular region. In this case, I have commented it as the code is applied at the global scale. We have the function apply scale factors. This is essential for working with Landsat level 2 data as it converts raw digital numbers into surface reflectance values. Let's define specific Landsat 8 bands we will use for the spectral mixture analysis. Here we are selecting 6 surface reflectance bands: blue, green, red, near infrared and 2 shortwave infrared bands. These bands are most sensitive to the spectral differences between the endmembers. Let's define the endmembers. Endmember signatures are representative spectral values for pure example of green vegetation, non-photosynthetic vegetation, soil and cloud. And these endmembers work well in many other countries as illustrated in non-Amazonian tropical forest in Schlouts et al. 2016, research on Ethiopia and Vietnam. Kusberg et al. 2017 experimented on Central Europe, and Heshmog et al. 2013 researched on Cameroon and Central African Republic region. If you are working in a different region, assess how well the index perform for different forest types in your region. The ratio of these endmembers that makes up the spectral signature of each pixel, which gives a good indication of the plant health and composition of that area. When the ratio shifts over time towards one or more of the endmembers, we can quantify how the landscape is changing. Now let's define a function for spectral mixture analysis, getSMAfunction function, and we use .unmix function in Google Earth Engine, providing our Landsat image and define endmembers. So this process estimates the fractional abundance of each endmember with each pixel. To derive the degradation index, we need to calculate the fractional images. First, we will calculate shade and then green vegetation shade. The shade fraction helps account for variation in illumination and topography. The green vegetation shade normalizes a green vegetation by non-shade components. The formula for green vegetation is given here, where GV is green vegetation and 100 minus shade is the percentage of the pixel that is not shaded, which provides the corrected estimation of the green vegetation fraction that is not obscured by shade. Let's derive remaining fractional images for different components such as soil, non-photosynthetic vegetation, green vegetation. We can identify soil as dominant when there are log landings or roads. Non-photosynthetic vegetation is high when there is canopy damage. Green vegetation represents fraction of a pixel covered by healthy green vegetation. High green vegetation is healthy forest, and decrease in values indicate forest canopy gap or degradation factors such as logging or disease and deforestation. Now let's assess a normalized difference fraction index. A balance between healthy green vegetation, non-photosynthetic vegetation and soil can give the illustration on the range of normalized difference fraction index. The formula to calculate NDFI is given here. Next, we will define the color palette for NDFI images. The range of the colored pattern is taken from the Souza et al. Research paper. Let's run the code and see. And you can also see the fractional images and NDFI image are displayed using map.add layer onto the layer. We can visualize the different levels of forest condition using NDFI image for year 2024. The values range from -1 to +1. +1 represent intact forest with a dark green shade. Degraded forest has a light green and orange to yellow color. Agricultural land with crops has pinkish color, and fallow and background are represented as a white color with values -1 on the map interface. The map is masked with cloud and water mask layer. We can define water and cloud mask separately as shown in the code. These steps are used to remove areas that could interfere with analysis, ensuring we are focusing on the land surface. When clicked on the layers, you can also see other fractional images such as green vegetation shade, non-photosynthetic vegetation, soil, green vegetation, and spectral mixture analysis. The combination of these fractional images are represented as spectral mixture analysis, and the map for SMA for year 2024 is shown here. I hope this video helps in understanding the importance of NDFI play in monitoring both deforestation and harder to spot forest degradation in tropical forests. If you have any questions, comment below and please subscribe. Thanks for watching and happy mapping.